Okay, so 13.5 describes making diols. That is alcohols that have two hydroxy groups in them. Two examples here are 1-propane diol, as you can see, 1,3-propane diol and 1,5-hexane diol. You can see that these are named essentially the same method. I need to get my pen here just a second. Essentially the same method, but do I have a pen here? Essentially the same method, but the suffix now is diol, right? You see that? Okay, so watch this. 1, 2, 3, 4, 5, 6 hex, or 1, 2, 3, 4, 5, 6, right? Still hex, but the 1, 2, 3, 4, 5 gives lower numbers, and so we use the 1, 5, right? The alternate would be to say 2, 6 hexane diol, but that would be wrong. 2, 6 hexane diol will be wrong because it gives bigger numbers, okay? And 1, 2, 3 is the same as 1, 2, 3. So 1,3-propane diol. Either way, naming those is no big deal. All right, so well, I shouldn't say it's the same thing as we've done before, except this time we use a suffix of diol. Okay, so one thing, there's 3 methods that we described in the previous section that we could make diols with. So we could take a carbonyl carbon here, right? Another carbonyl here, and we could simply reduce them to hydroxys, right? And that was method number 1 that we saw in the previous section. In the previous section, we used either palladium, platinum, or nickel, as I recall, right? I'm going to put a line through those though right here because just palladium is used here. The second method that we looked at in 13.4 was sodium borohydride with methanol, or remember what the other two were? With ethanol or with water, right? Okay, I'm going to put an X through those right now because 1 is enough, methanol. And the third method we looked at was lithium aluminum hydride. That was the third one we saw, and that was in 2 separate steps because the lithium aluminum hydride is so reactive it's going to get burned up with water and it's going to become unreactive. You're not going to have it for the alcohol because the water will mess it up, okay? So this was in 2 separate steps, 1, 2, and these were the 3 methods we learned in section 13.4. There was one more thing that we did in 13.4. I'm going to come out of here, keep those, come over to here, and the last reaction we did was taking an ester, right? Can you see this? 1, 2, 3, 4, 5. Okay. So what we did with lithium aluminum hydride was, in fact, this time I'm going to draw out the mechanism. This pen is a little bit too thick, isn't it? Okay, what happened was this guy comes here, bam, and goes here, bam, right? I'm going to go to a different color now. Go to a different thickness, and that gives right, and minus is here now, and the new hydrogen is here. Agreed? Can you see that? Okay. Then this guy comes down here, and this guy goes off as a leaving group. You remember that? Probably should have told you to do this. Oops, that's wrong. Should have probably told you to do this yourself. So I'm going to go 1, 2, 3, 4, 5, right? The same numbering I had over here. And I'm going to do this because I'm going to get confused if I don't. All right, there's my new hydrogen. That is here, right? 2, 3, 4, 5, and then it goes to the oxygen. Remember that? Okay, 5, 4, 3, 2, 1. Okay. And then this with that with a proton from water. Right, these guys come over here. Boom. It gets protonated. So I'm going to quit drawing that hydrogen now. I'm going to go ahead and leave that implicit. Agreed? You see what I'm doing here? This is still 1, 2, 3. Did I say I was going to quit drawing numbers? Okay. All right, and then the second round of lithium aluminum hydride. Notice I'm saying lithium aluminum hydride, but I'm leaving the lithium off here, right? Because it's just a counter ion. Here's my minus. So this guy goes here. Boom. Up. Boom. Right? 1, 2, 3, 4, 5. And let's see, what do I have here? Yeah, now another transfer with water. These guys come here, right? And I'm left with, watch this now. I think my screen doesn't like to write up that high. So let's go here and just say, I mean, I'm lost here now. Watch this. That'll be carbon 1, 2, 3, 4, 5. Okay, my does not like drawing up that high. Oh, get rid of this. Come on. Come on, come on, come on, come on. All right, where this, I'm going to call that X and this one Y. There's X and here's Y, right? 1, 2, I can't draw apparently that high. Oops, that's 2, 3, 4, 5. So here's another diol, right? And I got that by splitting an ester, which Klein does not show you here in section 3.5, but we did this in section 13.5. We did this in section 13.4. So I just want to remind you about that. Okay, so here's another way to make a diol. Yeah, it's a little bit ugly, but it doesn't help that my pen's not working very nicely right now. It also doesn't help that we're not in the same room together. But either way, there's another example. Let's go back to PowerPoint then and Shift F5. Okay, so method 1 from 13.4, method 2 from 13.4 was here, and that was the third one we looked at. And that is if we take a diketone or a dicarbonyl compound, and we can get a diol from that. Or we can split an ester, as I showed you just a moment ago. A cyclic ester, right? Okay, so let's move on now and say, but there were two other methods that we got in section 9.9 and 9.10, and those were anti-dihydroxylation from an alkene, okay? So these were a type of addition reaction, okay? And this was anti-dihydroxylation. That is, the hydroxides going opposite sides of the ring. And this is syn-hydroxylation, or rather, I'm sorry, opposite sides of the double bond, which if it's a ring, it ends up staying on opposite sides. And here's another one, osmium tetroxide in NMO, which is, I wrote the name down. What a booger name. It's N-methylmorpholine, something like that, N-oxide. You can just say NMO. Another... that's what this is, right? Another reagent that, co-oxidant that osmium tetroxide goes with sometimes is tert-butyl hydroperoxide. Okay, that's another possibility. Here's one. Here's another possibility, right? For syn-hydroxylation. That's in section 19, or rather 9.10. This was page 443. I should let you find it, shouldn't I? You know what? I'm not going to tell you what page that's on. Go find it. You'll learn it better if you go look for it. Go look for that. You could Google it, but anyway, go look for section 9.9, and that's the That's the way. That's two ways we got in Organic 1 to prepare diols. Yeah, so you've got not 5 new reactions, right? Well, no new reactions here, right? These 2 reactions came from Organic 1, and I'm going to go back a slide now. These 3 reactions came from section 13.4. So section 13.5 is simply applying the methods that you had before to make diols now instead of just regular old alcohols.